Welcome back. In this video, we will be studying another method of differentiation called logarithmic differentiation. Okay, so whenever you have a function of the type y is equal to f of x power g of x, or y is equal to f1 of x into f2 of x into f3 of x into so on fn of x, or y is equal to f1 of x into f2 of x into f3 of x, so on fn of x divided by g1 of x into g2 of x, g3 of x, so on into gn of x. Okay, you may ask me, for the last type we have u by v formula and directly we can use the quotient rule in differentiation and find out the solution. Well, that method is also valid, and this method also proves handy at times, okay, when the problem demands logarithmic differentiation. So these are three function types wherein you use logarithmic differentiation. Okay, so let's see the basic algorithm, how to solve these questions, and then go for illustrations, right? Let y is equal to f of x power g of x. Okay, what is that you use? What is that you do here? Apply log on both sides. Apply log on both sides. So log y is equal to log f of x power g of x. So we know log a power b is nothing but b log a. Okay, this is an identity which we know in logarithms. So log y is equal to g of x into log f of x. Okay, now you differentiate both sides with respect to y. Okay, so when you differentiate here, what is differentiation of log y with respect to x? First differentiation of log y, then differentiation of y. So what is differentiation of log y? 1 by y into differentiation of y with respect to x, dy by dx. Okay, this is equal to, here you can take this as a uv formula. Okay, first g of x into differentiation d by dx of log f of x, right, plus log f of x into d by dx of g of x, right? Is this clear? Now y 1 by y into dy by dx is equal to g of x into, what is d by dx of log f of x? First differentiation of log f of x, then differentiation of f of x with respect to x. Okay, this is the chain rule that we have studied earlier. What is the differentiation of log f of x? 1 by f of x into differentiation of f of x with respect to x into f dash of x plus log f of x into g dash of x, right? Now you take this y to the right hand side, dy by dx is equal to f of x power g of x into g of x into f dash of x by f of x plus g dash of x into log f of x. Alright, so this is a method in which you differentiate functions of the type y equal to f of x power g of x, and this method is called logarithmic differentiation. Okay, so let's look at an illustration, a basic illustration to understand this algorithm. Okay, now differentiate y is equal to x power x. Okay, so what is that you do here? Take y is equal to x power x. First, apply log on both sides. Okay, log y is equal to log x power x. Okay, so log y is equal to x log x. Okay, now differentiate with respect to x. How is that you do? Use the chain rule, 1 by y into differentiation of y with respect to x dy by dx is equal to, you can use the UV rule here. Okay, x into differentiation of log x 1 by x plus log x into differentiation of x, which is nothing but 1. So 1 by y dy by dx is equal to 1 plus log x. Okay, now take this y to the right hand side, dy by dx y times 1 plus log x. Right, what is y? X power x into 1 plus log x. Okay, so it's a very simple technique to work on the functions which are of the form f of x power g of x. Okay, so this is the first model in logarithmic differentiation which we have done. Now let's see how to use logarithmic differentiation on the second model. In this form of a function, y is equal to f1 of x into f2 of x into f3 of x, so on, into fn of x, where f1, f2, f3, they're all functions of x. Okay, that's how we have represented them. Now, how do you differentiate this particular function? How do you get dy by dx here? Okay, simply apply log on both sides. Okay, so applying log on both sides, this is natural logarithm. Okay, log to the base e. Okay, so log y is equal to log f1 of x into f2 of x into so on fn of x. Right, we have a logarithmic identity. For example, log a into b into c. This is nothing but log a plus log b plus log c. Okay, and this can be continued for any n, and this can be done for any n multiplications. Okay, so let's use this identity in logarithms. So log y will now be nothing but log of f1 of x plus log f2 of x plus so on plus log fn of x. Alright, is this clear? Now differentiate. Okay, use the chain rule. log y is nothing but 1 by y into dy by dx. This is equal to, here also use the chain rule, 1 by f1 of x into f1 dash of x plus 1 by f2 of x into differentiation of f2 of x with respect to x, that is f2 dash of x plus so on 1 by fn of x into differentiation of fn of x with respect to x. Okay, so now you take y to the other side, dy by dx is equal to y times f1 dash of x by f1 of x plus f2 dash of x by f2x plus so on plus fn dash of x by fn of x. Okay, now just substitute y. What is y? f1 of x into f2 of x into f3 of x. So dy by dx will be nothing but f1 of x into f2 of x into so on fn of x into f1 dash of x by f1 of x plus f2 dash of x by f2 of x plus so on plus fn dash of x by fn of x. Okay, so this is very useful whenever in generally problems they give you 4 functions or 5 functions, product of 4 functions, product of 5 functions. It's not that you cannot multiply them and take them term by term for differentiation, but this method proves very handy if the number of functions involved in product are more. All right, so let's take an illustration based on this method. So differentiate y is equal to 1 plus x into 2 plus x square into 3 plus x square. Okay, let's write y as 1 plus x into 2 plus x square into 3 plus x cube. So apply log on both sides. Let me write this y clearly. Log y is equal to log 1 plus x into 2 plus x square into 3 plus x cube. Okay, now apply log ABC formula, log a plus log b plus log c. Okay, log y is nothing but log 1 plus x plus log 2 plus x square plus log 3 plus x cube. Okay, now differentiate. Okay, 1 by y into dy by dx. Use the chain rule. What is differentiation of log 1 plus x? 1 by 1 plus x into d by dx of 1 plus x plus 1 by 2 plus x square into d by dx of 2 plus x square plus 1 by 3 plus x cube into d by dx of 3 plus x cube. Okay, so now 1 by y into dy by dx. This is nothing but, what is differentiation of 1 plus x? It's just 1. Okay, 1 by 1 plus x plus, what is differentiation of 2 plus x square? 2x. 2x by 2 plus x square What is differentiation of 3 plus x cube? 3x square. 3x square divided by 3 plus x cube. Right? Now take this y to the right hand side. Dy by dx is equal to y times 1 by 1 plus x plus 2x by 2 plus x square plus 3x square by 3 plus x cube. Okay. Now substitute y. Okay. Y is given 1 plus x into 2 plus x square into 3 plus x cube into 1 by 1 plus x plus 2x by 2 plus x square plus 3x square by 3 plus x cube. In order to further simplify, you can multiply this expression and let's write the answer here. 2 plus x square into 3 plus x cube plus 2x into 1 plus x into 3 plus x cube plus 3x square into 1 plus x into 2 plus x square. Okay, so this is your dy by dx equal to. So this is another method or another functional form wherein you can use logarithmic differentiation. Okay, so now we are done with the first two methods, two functional forms, and now let's work on the third functional form. Now let y is equal to f1 of x into f2 of x into f3 of x so on fn of x whole divided by g1 of x into g2 of x into g3 of x so on into gn of x. Okay, now apply log on both sides. Apply log on both sides. What is that you get? Log y is equal to log the functional form f1 of x into f2 of x so on into fn of x divided by g1 of x into g2 of x so on into gn of x. I already told you, right, this can be solved using UV formula also, but we will not be using UV formula here. Okay, it will defeat the purpose of us learning logarithmic differentiation in such case. But we will be proceeding the problem by applying log on both sides and using logarithmic identities and then differentiating and getting the final answer. Okay, the method is important here. It's not the trade-off between which method you have to use, either u by v formula or logarithmic differentiation. It is up to the student who is solving a problem, and it also depends. The judgment also depends on the type of problem that is being solved. Okay, so here differentiate on both sides. What is that we get? 1 by y. Before differentiating, now what is that we know? Log a by b is log a minus log b. Okay, also log a into b is log a plus log b. So let's use these two identities, okay, in the problem. What is that we get here? log y is log f1 of x into f2 of x, so on fn of x minus log g1 of x into g2 of x, so on into gn of x. Okay, now log y is equal to log f1 of x plus log f2 of x plus so on plus log fn of x, okay, minus log g1 of x plus log g2 of x plus log g3 of x plus so on plus log gn of x. Okay, now you can differentiate the left hand side. What is that? You get 1 by y into dy by dx is equal to this. We have differentiated in the previous case. What is that? We get f1 dash of x by f1x plus f2 dash of x by f2x plus so on plus fn dash of x by fnx, right, minus g1 dash of x by g1x plus g2 dash of x by g2x plus so on plus gn dash of x by gnx. Okay, now you take this y to the right hand side. Let's take it to the new slide here. Dy by dx is equal to f1x into f2x, so on fnx by g1x into g2x into so on into gnx into f1 dash of x by f1x plus f2 dash of x by f2x plus so on plus fn dash of x by f3x minus g1 dash of x by g1x plus g2 dash of x by g2x plus so on plus gn dash of x by gnx. Okay, as there are n terms here, this appears to be a little complicated, but as I've said earlier, it's a trade-off between the methods. Okay, which one is easy for you? You go ahead with that particular method. But this is one particular functional form wherein you can use logarithmic differentiation. Okay, now let's take an illustration and see how to solve a question using logarithmic differentiation. So I have y as x plus 1 into x plus 2 into x plus 3 by x plus 5 into x plus 6 into x plus 7. So keeping the uy method aside, so now let's take y as x plus 1 into x plus 2 into x plus 3 by x plus 5 into x plus 6 into x plus 7. Now apply log on both sides. Log y is log x plus 1 x plus 2 into x plus 3 divided by x plus 5 into x plus 6 into x plus 7. You can actually use this final form in case you remember it. Okay, let's use the identities and simplify. Let's directly write the simplified form. Log of x plus 1 plus log x plus 2 plus log x plus 3 minus log x plus 5 minus log x plus 6 minus log x plus 7. Okay, now differentiate on both sides. 1 by y dy by dx is equal to 1 by x plus 1 into d by dx of x plus 1. 1 by x plus 2 into d by dx of x plus 2 plus 1 by x plus 3 into d by dx of x plus 3 minus 1 by x plus 5 into d by dx of x plus 5 minus 1 by x plus 6 into d by dx of x plus 6 minus 1 by x plus 7 into d by dx of x plus 7. Right? Now keep the same term on the left hand side and simplify on the right hand side. 1 by x plus 1 plus 1 by x plus 2 plus 1 by x plus 3 minus 1 by x plus 5 minus 1 by x plus 6 minus 1 by x plus 7. Okay, now take y to the right hand side. dy by dx will be nothing but x plus 1 into x plus 2 into x plus 3 by x plus 5 into x plus 6 into x plus 7 into 1 by x plus 1, 1 by x plus 2, 1 by x plus 3 minus 1 by x plus 5 minus 1 by x plus 6 minus 1 by x plus 7. Right? This is the final answer. So if you know the final form of dy by dx, and when you are given generally 3 or more functions in the numerator, 3 or more functions in the denominator, it's better to use logarithmic differentiation rather than going with u by v formula. Okay, so we have now covered all the three forms, all the three functional forms for logarithmic differentiation, and I tried explaining using an illustration for every functional form. I hope now you will be confident to take up a question and solve using logarithmic differentiation. All right, I'll be back with another differentiation technique in the next video. Thank you.